Good afternoon, grade 10s. Today we're continuing with chapter 5, decision making, and we're particularly going to look at Boolean expressions and if-then statements. It's very exciting because now we can start making decisions in our programming, and it is a lot more fun. So we're going to look at the first part of module 5.2 because the entire module is quite long, but so we're only going to look at about 5 pages, and I'm going to do an activity with you, and the rest you're going to do on your own. So just to summarize of the work today, we have 5 pages, and we have these activity 5.2 I'm going to do with you, and then I'm still going to decide whether I'm going to do one of the practical examples with you, or whether I'm actually going to ask you to do that example yourself, because most of these activities are very theoretical. And only tomorrow in these activities you're actually going to work and do some coding and some practical work. So as I'm talking and processing this, I think I'm going to let you do one of the examples that I planned on doing with you actually on your own, so that you can see how it's done. And if you struggle, then I will just make another video on and taking you through that specific example. All right, so let's look at our textbook. So they are talking about Boolean expressions. There are 3 different categories. The first one is a Boolean variable. So that would be something like be found. Or so a Boolean that can contain 2 values, either true or false. Then we have a simple Boolean expression, and we have something that we call like a comparison operator. Something we can say, 5 is bigger than 10. Is that true? No, it's not true. So we are comparing 2 things with each other. So, and then it's either true or it's not. And then we have compound expressions, and they are actually discussed in module 5.3. But just so that you know what that means, is I can, for example, say IH equals 18, and I can say and, so the and compound, so both expressions need to be true in order for the entire expression to be true. And I can say here S nationality equals ZA, for example. So both of them need to be true for the entire statement to be true, and we can also have a compound with or, then only one of them needs to be true. Right. So I'm going to take that away to continue. So we have Boolean variables. As I said, we have got simple expressions with these 6 operators. So we have equal, not equal to, is it smaller than and a greater than sign, smaller than, smaller or equal, bigger or bigger than equal. Maybe to highlight one important thing is that the data types of either side of these operators need to be compatible. So we can have numeric data compared with each other, which is integer and real, but we cannot compare a number with text, with a string or with a character. So we can compare integers and reals, and then we can compare characters with string, but not with each other. All right. So here in the example, they say name equals CIFO. So this is either true or it's false. Same as with the mark, bigger than 30. If I enter the mark of 29, then this will be false. If I say 35, then it will become true. Let's look at the example that they've given. I'm going to highlight 2 things. So over here we can we have our variable declaration, and then they have been initialized with 7777. So IA, which is 7, equals IB, which is also 7. It is a valid expression, not because it is true, but because we are comparing two numerical values. This one, the fourth one, IA, which is 7, equals S word 1, which is 7. So if I would, if I would just speak about this and not show you and say 7 equals 7, you would say, yeah, that's true. But because there are two different data types, it's character as well, or it's string with a number, integer, so it's an invalid expression. So there would be an error message. Let's look at this one. IA minus IB equals 5. It's a valid one because both of them are numbers, but the result will be false because IA minus IB would equal 0 and not 5. Okay, then for activity 5.2, and this is the one that I want to do quickly with you, or just some of it, just to highlight, they made a mistake. Look at this. var, they are not declaring variables here. They are actually, I don't know what happened here. They were supposed to, yeah, you cannot just declare it with a number or a letter. So you would have to say here integer, string, character, just as it was done over here. So let's look at this. So all of them are valid. I've checked them, so we don't have to worry about that. But let's start typing the answers. So the result of this, let's see, AI, which is 2, is bigger than 2, would be false because 2 is not bigger than 2. And I'm not going to type the motivation now, you can do that yourself, but it's because 2 is not bigger than 2. Okay, then our next one, IA equals IB, would be true because 2 equals 2. IA bigger or equal to 2 would be true because 2 equals 2. So you get the hang of it. IA plus IB equals 0. No, it does not equal 0. It equals 4. So the expression would be false. IA diff 2 would be, how many times does it go in there? Equals once, right? 2 goes into 2 once. IA mod 2 would be a remainder of 0. So 1 does not equal 0. So our expression is false. S word 1, which is 7, no, it's jolly, is not C word 2, and that would be true. It is not, it's not equal. Okay, then we have S word 1 is bigger than C word 2. That is true as well because the J is bigger than a capital A. So over here we say true. C word 2 equals A, and that is also true because it does. Okay, and then the motivations, you don't have to really write that over unless you really want to, but I hope you got the the hang or the gist of this activity. All right, so let me take that away again and go over to now an if-then statement. If is kind of the questions. If something is true, and we always include one of our Boolean expressions after an if statement. So if something that you compare or something, a condition is true, then we can do this. We can also obviously if we don't want it to be true, if we want it to be false, we can actually use the, where is that now? Sorry, the not equal to. So, and then we have other operators called, for example, if not something, but we'll get there a little bit later. So for now, we use the comparison operators that I've just shown you. Okay, so you cannot, just something to keep in mind, you cannot use if and then as variable names. If you do, you will get an error. So you can't, call your string if, because that would be an error, because there are reserved keywords within Delphi. So here's a flow diagram. A decision is displayed as a diamond, and then it's either true or it's false. If it's true, something else will be executed. Otherwise, this one is skipped and another block. So what the parallelogram or the tilted one actually means something is inputted or outputted. So it's actually a wrong symbol over there. Anyways, okay, syntax, if, and we have a condition, and then we have a statement. I want you to note that, let's see if we have actual code here. I'm going to go down. Okay, over here. You can see if I points equals or is bigger than 2500, then I points. So you see there's no semicolon after then. So this is actually one line of code. And then over here we have the end of the if statement with a semicolon. And then this line is separate. Okay, so this line will be executed regardless of whether this condition is true or not. If I want to have more than one line of code or more than one action executed only if a condition is met, we have to add a begin and an end between these two. So you will have then begin, and then you can have more than one line of code, end, and then you will continue. I hope that makes sense. So in our examples that they're giving here is we have 1,000 bonus points to all its customers. So regardless of how many points you have, you get 1,000 bonus points. But if you have more than 2,500 points, you will get an additional 500 points. So our flow diagram looks like this. Our pseudocode looks like that. So we're reading in our points. If the points are bigger than 2,500, then we add 500 to our points, and then we add an additional 1,000 to all of them, and then we display the points. So our flow diagram looks like as follows. Start, read points, the beginning points. Then we ask, is it bigger than 2.5? If it's true, we add 500. If false, we add only 1,000. You can see if it's true, then it adds the 500, but it will also add the 1,000. And then we will display, and that's it. If we have a trace table, we can see now. Okay, in line 1, we read in 1,200. We're going to look at the condition. That the condition is false, so there's no output. Now we're going to add the 1,000 points, which is this. No more conditions, or no more, it's not ask again. And then we have an output of 2,200. If we start with 3,000, the condition is true, so we add our 500, then we add our 1,000, and the output will be 4,500. So this is the example, and I told you already in my introduction that I'm going to ask you to do this example activity on your own. The code for that example is actually given here, so you can code this. You could just copy and paste it, or you can actually try and do it on your own. And then furthermore, you can complete activity 5.3 as well as 5.4. And that concludes today's lesson. And then tomorrow we'll continue with some other examples and activities to consolidate our skills. Thank you, guys.